Good afternoon, good morning, good evening, depending on your time zone. So welcome to this 26th, I think, short course. Today we will focus on atmospheric dust. And we will do it with a big team of experts. So I am myself Federico Fierli. So I am a scientist and thematic expert in EUMETSAT, together with Rosa, that is Rosa Lucia, that is managing the course. But I will leave soon the floor to Julia Wagemann, that is a data expert and will present you the whole course with the new platform that we have developed recently. Sara Basart from Barcelona Supercomputing Center, Spain, that is in charge of the also of the dust forecast. Lucia from Italy, and Anu-Maija Sundstrom from Finnish Meteorological Institute. So they will introduce later. So just a couple of points. We have as usual, the questions on Slido, so on slido.com, and the code is EUMETSAT26. You can write in the chat box to support, to have help. Rosa will answer to you, and also keep audio and video off. Here is the website for this course, where all the material will be made available. So in a nutshell, we are, this is a course that is organized and hosted by EUMETSAT with the contribution of our partner. This will also happen in the frame of the Copernicus program, that is the European program for Earth monitoring, and this is built on the elements of observations, so with the development of Sentinel satellites that are supported and accompanied by ground-based data, and also from services that are a key multiplier for users' applications. So it's probably the most ambitious program that is now running in that sector, and EUMETSAT has the role to implement the programs that are satellite programs, plus a crucial number of sentinels dedicated to atmosphere. So there are, and there will be more and more data sets that are crucial for dust monitoring. So one of our role is beyond the production of the data sets, also to grant access, to help users, to make training, to communicate and to explore, and to help you as users to develop application. I just give you in 1 second what is the background of this course. For doing so, I will make use of a recent science story that we have developed for. It's published on the EUMETSAT site at the link that you see, and this describes the flow. A possible flow beyond the dust intrusion event that happened mid-March and was largely covered in the media. So these are the images coming from Sentinel-3, and we do observe a very intense northward transport, also with the generation of specific regimes that are related to the dust. But interestingly, we wanted to show that from the forecast, and this is a forecast that comes from the CAMS model, the CAMS CNR-IMAA model, and you see that the model has forecasted 3 days in advance the transport of dust plume reaching up Scandinavia and entering directly in Spain and France with very high levels of concentration, and that this is how the CAMS, how the BSC, the WMO, the WMO SDS system, so the dust forecast implemented by BSC, shows the same event in its initial phase.
Federico? You have also lost him?
Yes, I think, yeah.
Okay, so let's see whether he manages to come back. So he appears to be offline. There must be a network problem, as I cannot communicate with him. Yeah. So Julia, would you like to?
Yeah, probably we can start with giving an introduction to the online module, and if he comes back, then he could continue before we then hand over also to Federico is now back.
Okay, sorry, really sorry. It's go ahead, Julia. So basically, the message is that the joint usage of satellite and forecast is extremely important. I mean, to monitor, to detect, and to evaluate the impacts of dust events. I mean, the example was on Mediterranean, but I mean, dust is a crucial component worldwide. And then I will leave you to Julia Wagemann and to Anu-Maija, Sara, and Lucia, that are our panelists for the course. I don't take additional time. So again, I use Slido to put the questions, and again, any question is very good. And also at the end, we will provide a questionnaire, I think. So please provide your feedback. That is extremely important to us, and we try to develop. Okay, have a good course.
Okay, good. Thank you, Federico, and also welcome from my side. I posted some links now to the chat, and we're incredibly excited today because we would like also to launch a new online module on dust monitoring and forecasting today during this short course. And we have incredible experts on dust today with us, which we are very happy to have you here. So it's Anu-Maija Sundstrom from FMI, Sara Basart from the Barcelona Supercomputing Center, and Lucia Mona from CNR-IMAA. And I will give a short introduction to the online module. And this online module has three main parts. Two more theoretical parts that give you an introduction to different type of data related to dust monitoring and forecasting, but a content that is reflected on the online module. Anu-Maija, Sara, and Lucia will give you a short, more lively introduction. And then after the theoretical introduction to the data itself, we will then give you a more hands-on introduction to the data and how you can also make use of the online module and also the course platform which we developed. I share quickly my screen just to also let you know or show you how this looks like. So how you can access this module. It is available via the EUMETSAT's TrainHub portal, and you can access the TrainHub portal under trainhub.eumetsat.int. And there you will find different tabs and any or quite a few Jupyter Notebook and training resources that have been developed under EUMETSAT under different aspects and domains are accessible via this TrainHub portal. And today we focus on dust. And so you can either directly go here on the tab on top, on the tab dust to the online module, or you can also here browse below, and then you can open the module on the last tab here. And if you click on this tab, then you see an online module opening, which gives you first an introduction, what this course is about, what data is addressed, why also we developed this course, and also how you can access the course aspects. And then on the left, you see the different parts. So we structured it on observations and forecast models and the practical case study. So observations and forecast models give you an introduction to a very comprehensive introduction to different type of data. So observations, we distinguished again between satellite observations and ground-based observations, and then the chapter forecast models gives you a comprehensive introduction to different forecast data that is available to forecast and predict dust. And then, and this is, I will then introduce you more specifically to a practical case study, which you can then also make use of and working in a self-paced manner with the data and also with the content you learned. So you should really see this short course as a short introduction into this online module, which you can then go through for yourself also in a self-paced manner. But before I stop now, and I would first introduce you or invite Anu-Maija Sundstrom from FMI to give you a short introduction to observation data from satellites. And Anu-Maija, thanks for being here today, and the floor is yours.
Yes, thank you, Julia. So welcome also on my behalf. It's really nice to be here, and I hope now to give you a very short introduction on satellite data. So this is much of the similar material that is now available in this module. And this is basically a lecture that 50 minutes lecture that is squeezed in now into 5 slides. So this is really a short just the introduction what I do as a work, but also how you can obtain observations of dust from satellite observations. And so my name is Anu-Maija Sundstrom, and I work at the Finnish Meteorological Institute as a senior scientist. And my research topic and the data that I work mostly with is satellite observations of aerosols, trace gases, and all these kind of other observations also. So I'm going to now show you just very briefly, couple of basic things about satellite observations. So you might already be familiar with satellite data, but I still thought that it would be a good idea to kind of emphasize the thing that the passive satellite instruments actually, what they measure is the radiation that is reflected from the Earth and from the atmosphere back to the space. So solar radiation that travels through the atmosphere and reflects back to space. And therefore, the satellite measurements are always indirect. So satellites measure radiation, and then we need to have some kind of different kind of methods how we can then turn this radiation into some more meaningful and descriptive parameters. So basically, here is just I would emphasize here the figure that is in the lower panel. So here is basically the kind of the workflow, if you might call it. So how from a satellite radiation measurements, the radiation is then transformed into atmospheric observation. So we have the radiation measurement that is called level 1 data. Then we put that into a so-called retrieval algorithm. So it's a huge computer program. And after this computer program, we can get out some kind of estimates of atmospheric composition, for example, and that data we call level 2 data. And now what is kind of interesting, especially in this dust case, is that we can already from this level 1, so this radiation measurements, we can get information on dust. So dust is very visible quite often in these really kind of a basic RGB, so this RGB type of images of satellite observations. So you can see the dust in the upper level 1 image as a kind of this yellowish brownish cloud over the Atlantic Ocean. Then we also have some kind of other kind of derived products that are also composed of the level 1 data. So basically the advantage of this data is that they are typically quite quickly available, so you don't need any specific computer programs to produce this kind of material. And then on the other hand, we have this level 2 data, which requires special retrieval algorithms. But from these level 2 data, then about these atmospheric and aerosol observations, you might get a little bit more information what is going on. For example, an estimation of aerosol loading, so how much there is dust approximately in an atmospheric column. So this is also the examples that you will find in the training module, but there is different satellite observations that can tell different things about dust. And typically I took this example just to kind of illustrate that how this kind of different parameters, and when you combine the information from different sources, so can give you a more broader view on the analysis of different kind of dust episodes. So maybe this is my last slide. So I just wanted to kind of summarize a little bit what the satellite observations are good for and what you need to have some caution when you are using these observations. So basically, in this course also, all the satellite observations that are considered are from passive satellite instruments. And so the passive means here that they use either solar radiation or then thermal radiation. So they don't have their own light source or signal that they measure. And so the kind of the satellite observations can provide you a global and large-scale view on the dust episodes, and also a large-scale view on the long-range transport episode. So when the dust is transported, let's say from Africa to Caribbean, so you can follow with the satellite observations, you can quite well get an idea where the dust plume is going. And also the satellite observations can provide you information on dust in a total atmospheric column. They are very useful for this kind of quick looks, as you have here an image. This is an RGB image again. These are very good for just to kind of have the first guess and the first estimation where the dust is and possibly how strong it might be and how large area it covers. And also you can, when you combine these different kind of satellite observations, so you can estimate the dust plume characteristics on a large scale. So for example, how much there is aerosol. So what is the aerosol loading in a total atmospheric column? But then there are a couple of important things to remember when you are using satellite data and working with satellite data, what the satellite and the passive satellite instruments cannot do. And first of all, they cannot give you information about the surface concentration. So these passive satellite instrument measurements always represent the total atmospheric column. So to get really an information how much there is dust on the surface and how much does it affect to the air quality and on people's life. So there I would always recommend to use some kind of additional information from other sources. And also these passive satellite instruments cannot see below clouds. So the clouds block the view below them. If you think you are on space and look down to Earth, so you cannot see what is below the clouds. And this is the same thing for the passive satellite instruments. So these are these kind of restrictions that you should always remember when you are working with satellite data. And as a final conclusion, I would say that satellites are a really good source of information, but the best view on a dust episodes you will get when you combine the satellite information with model in situ data, for example. So it is always a good way to kind of do the analysis so that you use observations from multiple sources. So this was my really short introduction to the satellite data, but as said in the module, there is a really good material now on satellite observations, and you will get a really good information and basic information what you need to know if you want to use satellite data for dust monitoring. Thank you.
Thank you, Anu-Maija, for this great overview and summary about satellite observations. We have one quick question which you could respond to quickly. If I understand the question is correctly, so are RGB images or composites clearer at night or day?
So it depends on which kind of composites you use. So these are dust RGB composites that uses the thermal channels. So they might be actually somewhat more clearer, let's say. It really depends on the temperature of the surface, etc. So there are these kind of contrasts. So when the contrasts are large, then the RGB images are also kind of good. But this holds only the nighttime observations you can get only from, for example, this Severi type observations that uses the thermal channels. So for these RGB images that I, for example, showed in my last slide, which are the composites of the solar channels. So for there, you need solar radiation, and those images are not available during nighttime.
Okay, great. So we have some other questions, but we will then respond to them after the talks also from Lucia and Sara. So thanks, Anu-Maija. So now I would introduce or invite Lucia Mona to give a short summary and introduction about ground-based observations that can be used to monitor dust.
Hello, everybody. I'm very happy to be here for showing you something about the dust ground-based observation. Of course, I just pick some of the slides that you have that you can use as a reference. I just want to, first of all, to introduce myself. I'm Lucia Mona. I'm a researcher. I work at the CNR, the National Research Council of Italy. And I'm part of ACTRIS. ACTRIS is the European Aerosol Clouds Trace Gases Research Infrastructure. What does it mean? That this is a combined effort of European countries for providing a platform for investigating aerosol clouds and trace gases. So as of interest of this session, we are more focused on the aerosols. And I just want to pick for you some relevant points, so which are related to the dust observation. So first of all, how and why we need to extract the information about the dust among the different kinds of aerosols. This is a very relevant topic. Why ground-based observation can be of interest, because we saw that from Anne-Marie, and we will see from Sara how models and satellite can provide a very wide picture of the aerosol content and of the dust content. And then specify that we have three kinds of measurements from the ground, which are the measurement at the surface, columnar measurement, and profiling measurements. Of course, I will not go into details, but just giving you the take-home message about these 5 points. For what concerns the dust component, it's clear that into the air we have a lot of particles. And if we want to investigate about the dust, so the aerosol that comes from mineral sources, then we have to identify the dust component into the complete aerosol scenario. And the first point is understanding what we are meaning with the word dust. And then that each one of the technique for taking measurements then use different methods for discriminating the dust with respect to the other aerosols. And this is very important to have this in mind. Then why ground-based measurement can be important? They can be important because they can provide a wide kind of information. from chemical to related to the dimension of the particle, to the vertical layering of the aerosol, so where they are into the column, and much more precise information respected to the satellite one, and to be used for the model evaluation. So they are really relevant for the validation of the satellite, for providing knowledge for improving the algorithm for satellite, but also for the model evaluation, and also for the development of new methods. And this is because of the higher possibility to control the measurements when you have a ground-based measurement, and because some strictly quality assurance and quality control procedure can be implemented. And this is true, for example, in networking activities. And also because, for example, during campaign, you can put together a lot of instruments to be compared and synergistically used. This just I go first. This is just for showing you that when you have measurement at the surface, for example, collecting the aerosol and then investigating them into the lab, you can have a lot of information. So the content about black carbon, for example, the size distribution, the chemical composition, the dimensions. So a lot of information can be obtained. When you have the columnar, what you are doing with the remote sensing columnar measurement is just to look to the radiation coming, for example, from the sun or from the moon, and have an idea on how the atmosphere attenuates and modify this radiation, and from this getting the aerosol optical depth. So how the aerosol modify this accumulated radiation. And for what concerns the dust, it's possible to obtain from this kind of measurement the dust AUD. That means the component of dust. And for doing this, there are some criteria that can be used. They are different. I just list 3 here, but there are many. And so, again, it's important to understand that there are some assumptions when you identify the dust component. And this should be kept in mind when comparison and integration are done. And this is just one example. This is how the optical depth change during the time, and is around this value. At a certain point, there is a big sharp increase into the data, and this can be related to the presence of a strange event. And if you look to another parameter, which is the angstrom exponent, this is a parameter that gives an idea of the dimension of the particle. Low numbers means large particles, and you can see that in the same period, the dimension of the particle is larger, and this is related to the presence of dust. This event will be part of a hands-on analysis, and this is also the ratio between a big particle and a small particle, the opposite, sorry, the small over the large one. And this is one example of the vertical profiling. So while with the columnar remote sensing, what you see is an accumulated information inside the column, the atmospheric column. When you have the vertical profiling, so in this case, the LiDAR observation, what you can see is time by time, this is the x-axis, you can see time by time the presence of the aerosol at all the altitudes. So here I reported from 1 kilometer to 13 kilometers above the sea level, and different colors stays for different intensity of the LiDAR signal, so larger presence of the aerosol towards the warm colors. And you can see that there is a very tiny layering into the atmosphere, and so you can understand that when you look just to the columnar information, you lose all this kind of info. And this can be really important for understanding the impact on different sectors. And then just for saying that there are new products under development, and this can be really interesting because we can have easily target classification. So getting the information about aspherical and large particles, and even practical identification on desert dust and volcanic, for example, that can be of interest for the aviation. So I don't want to take more time from your side, but just give you the main messages. Then you can find all the info into the longer presentation. So dust contribution can be obtained by different techniques and different methods. The methods are different, and these differences have to be taken into account when you make the analysis and discussing the cases. And then, of course, there are pros and cons for the different technique. And with this, I stop my short presentation.
Thank you, Lucia, and thank you for this great summary and overview of ground-based observations for dust monitoring. So just for everyone to know, we will address the questions on Slido just after the presentation from Sara. But now I would like to introduce you to Sara Basart from the Barcelona Supercomputing Center, and she will give you an overview and short summary about model forecasts for dust forecasting and prediction. So hello, Sara.
Hello, good afternoon. Thanks, Julia, for the introduction. As Julia introduced me, my name is Sara Basart, and I'm based in Barcelona in the Barcelona Supercomputing Center, that basically is the national supercomputers facility in Spain, meaning that we are devoted to develop numerical models, atmospheric numerical models. Then my research is mostly focusing in mineral dust modeling, and this is the reason why I'm here, but also because my contribution to this WMO SDS was a regional center. That SDS was means Sun and Dust Storm Warming Advisory and Assessment System Program. That is a program from the WMO. And I'm glad to say that I'm the lead scientist of this center that I will introduce today. Basically, you have to be aware that the dust cycle is basically composed by three processes, that is the emission, the transport, and the deposition. That is basically the removal of this dust from the atmosphere. And as you can see in this image, that is a model simulation based on the NASA GEOS 5, you can see that all aerosols that are dominating the global aerosol budget, that is the organics, dust, sulfates, and sisal. And if you take a close look to the dust, that is this orange color mass, you will see how in North Hemisphere is where we can find the most abundant amount of dust, basically because the Sahara, the Middle East, the Chinese deserts like Gobi and Taklaman, but also there are some areas in the world that are also emitting dust, like in North America, South Africa, even here, and also Australia. Then for that reason is important this topic of dust. And why we have to be aware when we are doing this modeling of the dust cycle, because basically we want to search the way that we can represent this dust cycle into a numerical model. Then in this case, we have to be aware that there are two things that is very important. For the dust emission, we have to consider a time and a spatial scales, because the dust emission is sporadic and especially heterogeneous because it depends on the localization of the sources. But also in the transport, this is more relaxed because the transport is more long-range transport, then the associated scales are a little bit different. Then the challenge is to balance these very high resolution processes related with emission with the more larger scale resolutions that are related with the transport. Also, you have to be aware that dust emission, transport, and depositions are super sensitive to meteorological variables. Then for us, it's critical to have a well-represented atmospheric weather situation. And the most important things for the dust emission, for example, is the surface wind speed, also the precipitation, and other factors. But basically, you have to be aware that any dust forecast, it will depend on the quality of the meteorological forecast. This is my first message. And why is important? Because the meteorological phenomena that emits dust are linked with different weather situations. And we have to be aware that not all the models are capable to reproduce all the time and spatial scales. We are very good to reproduce these more synoptic data storms because they're based in a very well structured and predicted situations. But if you try to reproduce these dust devils storms, for example, this is really like a challenge for the current models. If you are working with a synoptic model, for example, then you have to be aware also about the type of phenomena that you are trying to do focus. And basically, in the scope of the models, why is so important the information coming from satellites and in situ observations? Because we are using this information for model evaluation. We need this information to assess the quality of our forecast, but also to detect what processes are missing in our schemes, and also for assimilation. In that way, we can correct some errors in the model that with the information provided by the observations, we can balance. Then this is the most important functions of the satellite products and in situ and remote sensing information in modeling aspects. And in this context, you can see that there are many impacts of the sun and dust storms in our society. It's not just weather and climate, it's also life, ecosystems, and infrastructure. And for that reason, the WMO launched this WMO Barcelona Dust Regional Center that you can visit us in this address. Also, we are having this Twitter account. And basically, the Barcelona Dust Regional Center is coordinating the activities in Northern Africa, Middle East, and in Europe of this SDS WOS program of WMO. That basically has clear objective. We want to identify products that will be beneficial for the users, facilitate the access to this information, but also to teach you on the use of this data. And basically, the system is organized through 3 nodes that are coordinated by regional centers. And in Barcelona, we are hosting this center that is hosting these activities in Northern Africa, Middle East, and Europe. Also, we have the commitment to provide operational dust forecast to the users. Then it's why this region we are keeping this broad context of work. And basically, if you visit our website, you can see a new visualization tool that will help you to access to 15 different regional and global models. Also, you can evaluate them if you go to this part of the dashboard with IRONET and MODIS data. The important thing is also that you have this multi-model product that is the median of all the available models for the forecast day, and is the product that you will use in the module. And also, if you can see in the list, you have also the CAMS global model. And here, for example, you can do comparisons between different models. Also, you will find different models based on modeling that are oriented to a specific use, like the probability of accident or some initial work for warning advisory systems. And another feature that can be interesting for you, and I think that is included in the module, is the access to the numerical data that now is through a server that is this threat system server that we will hope that facilitate you the access to all the numerical data. And also a last comment that is important for us is all the work that we are doing for the capacity building. And today is a good example. Through these trainings, we want that the users can come to us and then has some access to any kind of observations and models, but also has some knowledge on how to use them. Then for that reason, we are organizing trainings in collaboration with EUMETSAT as today, but also with other institutions. And in the website, you can track all the events that are upcoming in the next weeks, and also past events. You can get access to materials of past events. And just for your information, next week we have a webinar that maybe is in your interest, that we have the invited speaker is Jasper Koch, that is a well-known dust scientist that has a lot of expertise in different aspects of the dust emission. And next week we'll talk about the impact of desert dust in the giant particles of desert dust in the climate context. And with this, Julia, this is my introduction.
Excellent. Thank you so much, Sara. I would just ask Sara, Anu-Maija, and Lucia to stick around for another 5 minutes if possible. We have some questions And the first one would be related or is addressed to you, I think, Sara. How do I distinguish between the dust that, no, sorry, this is to Anu-Maija, but we had like here, I just highlight this one. So why the choice of multi-model median? Why not mean? You're muted,
Yeah.
Sara.
Yeah, this is for me. As why we are using the median? Because the reality is that we are accepting all the models that wants to participate in this multi-model ensemble. And sometimes we detect that there are some models that has strong deviations that are affecting to the mean. Then the median is more conservative to avoid these extreme values from some of the models that can really not destroy it, but can really like give poor skills to the final product. It is basically because we are having a conservative approach, but also we were testing the mean, and at the end the best product was the median. Yeah.
Okay, thank you, Sara. There is then a question. This is more for Anu-Maija. So how do I distinguish between the dust that's stuck and the dust raised by satellites? I saw that you also provided already a response on Slido, but maybe you can just give a response also here.
So I have been answering the satellite questions in Slido already. So basically, if I understood this question correctly, it is meant that how you can distinguish the dust that is lifted up like with the wind, so which is in the air and which is then like lays on the ground. So for example, in these RGB images, so typically when the dust is lifted in the air, so it creates on top of the in the satellite image, it creates this kind of like you would have a semi-transparent blanket on top of your surface, so you don't see, for example, the surface characteristics so sharply. But when there is no dust or any other aerosols for that matter, so then you can really see even over the Saharan desert, for example, the surface characteristics quite sharply. So when the RGB image becomes a little bit like a hazy or like there is some kind of semi-transparent layer on top of the image, so then you can maybe guess that there might be a dust in the air. Then if you go to level 2 products, for example, the absorbing aerosol index only picks elevated dust, so it doesn't react in any way if the dust is laying on the ground. So you need to have dust up in the air so that the absorbing aerosol index can pick that up. So that is one. So I hope this answers the question.
Okay, thank you, Anu-Maija. Then we have another one for you, I think, or in general, can air quality monitoring in coal mining areas, can this be done? Is there any additional information required? If what are those data?
Yeah, so basically, certainly from the coal mining areas, I think aerosol emissions can be a one potential like a pollutant that is appearing in the area. So satellite observations, you could study that coal mining area and see compared to the surrounding areas whether there is, for example, higher AOD than in the surrounding areas. But I would also here emphasize that the satellites cannot give you the surface information, so the surface concentrations are not obtained from satellite observations. So in order you to be able to really analyze what is the air quality, like the precise air quality, whether some thresholds are exceeded or not. So for that you would need some kind of other observations. And also in addition to aerosols, so this coal mining, I would assume that there are also some emissions of different gases. So you might be then also combine information with aerosols and different gases from satellites. But overall, like you can get a general idea whether there are emissions, whether there are elevated values from satellites, but then the exact air quality. So for that you would need another type of data.
Okay, then we have a question. How can I know the exact height of dust and its size from satellite images, or are there other tools?
So yes, there are maybe the best height information is obtained from the active remote sensing, which I think Lucia in her presentation there is a talk maybe about ground-based lidars, but from satellites. So there is also lidars on board satellites. So from those you would get the height information. But there is also from passive instrument this absorbing aerosol height that can give you some estimation about the plume height, where the plume is. But the limitation for that parameter is that you need to have quite a large episode, so quite strong episode, so that the signal is strong enough so that the estimation of the height can be made. So, and then about the size distribution, I think this is about size, like is it height of dust and its size? So maybe if you mean like aerosol, like the dust, aerosol size distribution. So from satellite instruments, you cannot get information, or some information maybe, but that is really uncertain. So I would say at this point that you are not getting aerosol size distribution information, but for example, from AirNet observations, there are retrievals that provide and the size information, for example, the Sundstrom coefficient, and then there are also some other parameters that could be used for estimating the size distribution for dust. But from satellites, I would say that the size is no-go at this moment.
I can say something also.
Sure.
Because they mentioned another tools. I was thinking also not just satellites, it's lidars. It's giving you perfect, it's higher quality on the definition of the height, as Lucia can also mention. But in going to my area, I would say that always models can complement the information coming from satellites. Models is giving you a 4D because it's spatial and temporal scales, and you can also use models for supporting your analysis. This will be the nice thing, combining different tools.
Yeah, can I add something?
Sure.
Yeah, okay, so just for mentioning, Marie already said that there are some lidars on space which are providing interesting information about the height of the dust worldwide. There is Calypso, which is flying since 2006, and so it's providing something like more than 15 years of information about this. So providing for the first time ever the precise information about the altitude where the dust is transported, and it was really nice to see that. And Calypso, I think that it will end its life in orbit soon, because it's a very long mission. It was unexpected long, but Earth Care from ESA will be started soon. Now it's planned for next year, and so there will be the continuation between these two satellites. So it's very nice to have. And I want also to add another aspect of interest. LiDAR from the space can see the dust even above the clouds, while instead the LiDAR from the ground can see the dust below the clouds. So combining this information is really interesting for understanding also the impact of dust on the cloud formation and on the radiation budget in those cases, which can be really relevant. And then, as Sara said, models can provide the 4D distribution of the dust in time and space. And again, the combination of all these tools, so satellite, ground-based measurements, and models, will always provide a better insight of the processes behind them. Yeah.
Thank you, Lucia. I also see Federico raised his hand.
Yeah, can I add one point, Julia? So it's
sure.
yeah, okay. I quickly share my screen. So
okay.
I mean, I just go back to what I wanted to say, and then I was thrown out. I mean, in fact, during this event, the models they forecast the uplift of the dust. I mean, on a baroclinic frontal, so in meteorology, and then in fact these layers were expected to be at around 7 to 8 kilometer height, and then transported efficiently northward. And what is interesting is that in presence of clouds, so you can, for instance, as Anu-Maija said, you can use, for instance, the AI that is less sensitive to clouds, and you can see that effectively the aerosol arrived here in Central Europe. And most interestingly, in fact, you can check with the Calypso here. You see, for instance, with the blue box, in that case, it was the infusion of dust in high, let's say, quite high altitude clouds. So these were quite closer to the tropopause height. And that is an example on which calliope can really, or a LiDAR from space can really help in verifying the efficiency and the dynamics of the process. So I think it's a very valuable information. Then here below you see, in fact, the dust layer that is visible below the clouds here in that part. So here in the red box. So basically, that's I mean, I support totally the message from Sara and Lucia on this.
Okay, great. Thank you all. I just go back. So we have still a bit of questions, which is also good because this shows the great interest in dust. So I think the next question is for Lucia. So from those listed ground-based observations, which of those resemble satellite measurements? This is how I understand it. And is there a bias between ground-based and satellite measurements or observations?
Okay, I will not give numbers about parameters or similars, but the main concept. The concept is that the ground-based observation can be used for validating each one of the satellite measurements. So let's say MODIS satellite observation about the dust, or Calypso observation about the dust, and ground-based observation can be used as a reference for these and for the different parameters. And what is typically happening is that based on these validation studies, then the algorithm from satellite observation are retuned or corrected and improved, so that also the quality of satellite observation is improved as a whole. And also that there are some efforts at the satellite community, maybe Marie can also comment on this, to try to provide something like a continuous data set from different sensors and satellite for getting long-term data set from satellite for the different aerosol properties. And this is done under some project at ESA level. And of course, this kind of bias and uncertainty can be taken into account, and they are always documented through scientific papers. And typically, satellite data are also accomplished with this uncertainty into the data.
Okay, thank you, Lucia. So then the next question. So when the dust has accidentally mixed with local water vapor droplets in the atmosphere, how would that affect the original dust signature in imagery and image interpretation too? So it's probably more related or more for Anu-Maija.
Yeah, interesting question. Like when you are looking at the RGB images, for example, so there is like with just simply by eye, so visually, so that you don't like retrieve any additional like indexes or anything. So it is really difficult then. So the dust quite often it disappears to the cloud. So then it's not if it's inside, if it's mixed in the cloud, for example, it's not visible anymore in these RGB images. So whenever this happens, it's impossible. So that also caution when you use satellite data. So if you at some point disappear, like if you lose the signal from a dust plume, so maybe good to check the models and other observations, so that if it's is the dust like deposited on the ground, or is there just that the clouds are now messing up your whole imagery and your data. So always also this kind of sudden disappearances. So for example, one good example was a year ago, that this dust episode when the Saharan dust came all the way up here north to Finland. And it was somewhere over to Germany that from the satellites, we lost the signal completely. So we couldn't get any information from the satellite data anymore, but still the dust ended up here up north. And the thing was that the dust was actually mixed to clouds, and it was then snowed down here in Finland. So it came down with the snow. So also this is a good question, a good thing to remember when using satellite data.
Okay, thank you. So then the next question, can one use weather radar data with satellites to assimilate into the model, and what would be the results? It's more for Sara.
Yeah, this is for me. In fact, numerical weather prediction models, that is basically weather models, used to assimilate radar data and surface observations. It's true that in our case, we are not using this type of meteorological models with assimilation of radar information, but it's possible. If you improve the meteorological forecast, assimilating observations in the meteorological part, in the weather part, of course, your forecast will be always better. But it's true that in the current aerosol forecasting models, we used to work focusing in the simulation of dust observations or aerosols observations. But yeah, assimilating observations always for forecasting of purposes is welcome.
Okay, thank you, Sara. Then the next one is also for you.
Yeah.
It's a question about haboobs.
Yeah, haboob is basically a convective sun and thunderstorm, meaning that you have a convective cell. It's typically in summer when you have this strong convection that goes the downdraft of air, and this downdraft of cold air is pushing at surface the amount of air, and then it's causing the emission of dust. It's called haboob because it's very typical phenomena in North Africa, and is an Arabic word just to define this type of walls of dust that suddenly appears. That is basically these haboobs. And you never saw it. Okay. Yeah, I mean, it's really like something common. Haboobs is a common name in North Africa and Middle East. And is that connected with them? Yeah, as I said, when you have convection, then you have this downdraft of cold air that is causing the emission of dust at surface. Yeah, it's very extreme events. Is one of the most extreme ones. Yeah.
Okay, thank you. Then the next question: is data available also on a global scale? And then specifically for MODIS data, if there are any scale factors?
Data means observations or models?
I think in general, probably. So maybe you can give your perspective on models, and then also Anu-Maija can say something.
Okay, there are global models as the CAMS global model or MERA or other global models that are available, but also you have the regional runs that are focusing in a very specific area of the world, like the CAMS European domain or the regional models that are considered in the WMO, the Barcelona Regional Center, that are covering the specific region of Northern Africa, Middle East, and Europe. This is my answer, Julia.
Okay, Anu-Maija, would you like to say something about? Yeah.
So the MODIS data is available from several sources globally. In fact, there are two MODIS instruments. So MODIS Aqua, which is on afternoon orbit, and MODIS Terra, which is on before noon orbit. So there are actually two MODIS instruments operating two different satellites. Do you have any scale factors? So I don't know exactly what this means, but if you refer to AOD data, this is actually a very good question, because MODIS provides the AOD as a numbers that needs to be scaled with a scale factor. So if you read MODIS files, MODIS AOD files directly, you will get too high numbers. So there is a scale factor, if I remember by heart now correctly, is you need to multiply these numbers that you get by 0.001 or 0, something like that. So your AOD should be varying from 0 to about 3 at maximum, but most likely from 0 to 1. And so, yeah, so if the scale factor refers to AOD scale factor, so yes, they are provided in the file, and you should always use this, otherwise you get really wrong numbers.
Okay, thank you. So we are almost there. So the next, the second last question is, how does relative humidity affect dust deposition? Does it make the dust stay longer? And if yes, why?
Okay, I will take the, you can help me on that, Lucia and Anu-Maija, but I will take the role. Okay, you have to keep in mind that the mineral dust, as mineral dust, is usually non-hygroscopic, meaning that it's not absorbing water. Then the water is important when it appears in a precipitation mode, because if you have a dust cloud below a rain cloud, obviously the rain will scavenging, will clean dust from the atmosphere, will remove all the dust from the atmosphere. And in that way is affecting dust deposition because it's correlated with the precipitation. Does it make, no. On the contrary, if there is precipitation and you have a wet deposition of dust, obviously it will be removed faster than if you don't have this precipitation. And as I said, dust is not interacting with humidity, meaning that this aerosol is not changing the, it's not hygroscopic, then it's not changing the properties of their size or composition because the presence of humidity. But it's true that if you have precipitation, of course, it will be removed. Sometimes, if there is the conditions that are current, I mean the correct conditions, dust can be an effective ice nuclei, but it should be a very high altitudes and probably northern latitudes. But itself is not changing its properties. Yeah.
Okay, thank you, Sara. And the last question, probably for Anu-Maija, how can we distinguish light absorbing particles like dust and elemental carbon through Earth observing satellites?
So basically, if you mean that overall, like absorbing particles from everything else, so these absorbing particles leave their fingerprint in the UV part of the radiation, and from that we can calculate so-called absorbing aerosol index. But that doesn't distinguish which kind of absorbing particles they are. So if the absorbing aerosol index shows that there are absorbing aerosols in the atmosphere, then it is upon to you figure out whether it's dust, smoke, or volcanic ash. But then to distinguish from satellite measurements the absorbing particle types from each other, that is $1 million question. There has been a lot of attempts, for example, to kind of distinguish black carbon, etc. This kind of so the kind of the obtaining the aerosol properties, optical properties from passive satellite instruments, and I underline here passive. So with LiDAR you can get, again with active remote sensing, you can get a little bit more further with this than just with passive satellite instruments. So maybe Lucia, if you want to say something about the aerosol typing from active.
Trying to unmute my microphone. What I think is interesting for discriminating dust and elemental carbon from active sensors would be the depolarization, the measurement for the depolarization, because this provides more information about the sphericity of the particles. And also, I think that combining different wavelengths, you can get information about the angstrom and so about the dimension. And this also goes in the direction of discriminating and identify larger and spherical particles, which are typically the dust particles. Then still remains some, let's say, confusion with the volcanic particles, because they are also large and spherical. Yeah. So it's not really easy to have the precise typing for everything. This is an open question, not only from satellite, but also for ground-based measurements. And again, integration is the key, because using together active, passive, and sampling measurement, this could be a way for understanding better where we can see differences and which parameter we can find the critical point for discriminating between the different kind of our resource. Yeah.
Okay, thank you, Lucia, and thank you, Anu-Maija. And so we will take now one final question, which just came in, and then we go to the practical part, because this question is actually a nice bridge between now the theoretical part and also the practical part. So what resolution do satellite images have, and is it possible to capture the dust particles with the current resolution, and for how long is it possible to make to do the forecast for dust? So it's for Anu-Maija and Sara.
Yeah, I can answer shortly the satellite part. So depending on the instrument, so the resolution can vary from tens of or hundreds of meters to tens of kilometers. So 1 pixel resolution can vary that much. For dust particles, like the particles really themselves, it is not possible to capture like the small amount of let's say you need to have some kind of particle population there in order to catch that with satellite observations. So I think that would be my short answer. So resolution changes from tens of meters or hundreds of meters to several tens of kilometers.
How long is possible to make forecasting? I mean, we consider short-term forecast everything that goes from today up to 10 days, approximately, like 2 weeks. Then from weeks, it starts another type of runnings that we call seasonal and subseasonal, that goes from weeks to months. And then you go for another type of simulations that are the climate projections, that are the ones that are the experiments that we include in the IPCC reports and things like that. Then if you think in forecasting, regional models we used to go from 3-4 days, and then global models is giving you 5-6. And some of them are using observations from satellite in the first hour, like the first hour of the run, then includes the best initial conditions for the run of the forecast. Yeah.
Okay, so thank you, Sara, Anu-Maija, and Lucia for this great overview and introduction to everything related to dust monitoring and forecasting. So I will now, so we can now take everything we learned from Sara, Anu-Maija, and Lucia, and use this to get an overview of the specific data on observations, but also for model forecasting. And so basically, I start sharing my screen. I just close this one. And I would basically just give you now a short overview on how to use the online module which we developed. So what we want to say is, so all the introductions that you received from Anu-Maija, Sara and Lucia are there on the online module under the respective section. So if you go to observations, remote sensing satellite, then you get here in detail an introduction to satellite remote sensing for dust monitoring. And then under this section, we provide you an introduction to 6 different satellite images or satellite data that can be used to monitor dust. And the same is then if you go to ground-based, and this section covers ground-based remote sensing and in situ. So there you also get, again, an overview of ground-based measurements, and then specifically we highlight 3 different data for measurements at a surface. For columnar remote sensing, there we highlight the AeroNet data and observations, and also one example for LIDAR remote sensing. So, and if we go to an example, here, these are really practical data discovery and data introduction parts where we specifically introduce you to the data and give you a hands-on introduction on how you can use the data. So where you can get the data, how you can retrieve it. So if you have to download it, and if yes, where is the system to download the data, or if you can download the data programmatically. And then also in what format the data is coming. And then we also show you how you can, with Python, start working with the data and visualize the data. And then under the forecast models, again, we have here an introduction part that covers a general overview of different models. So data from from global models, from the CAMS model, but then also highlighting specifically the regional dust forecasts from the WMO Barcelona Dust Regional Center, and also from the CAMS European Air Quality Forecasts. And then again, for these 3 data sets, we have here a hands-on introduction to the data. So if you open the online module and you go to a specific data introduction, you will see here on top a hint box, and this refers to execute a notebook on the training platform. And this is how the online module works. So we have this website which is accessible for you in a static way. So this is more like an online book where you can browse the content and you can study and you can read through it. But then we also have another part, and this is like the course platform, which is based on a Jupyter Hub. And if you go to this link, then you can directly access this notebook on the course platform. And I will now highlight or show you how you can register and access this course platform, and how you can also navigate your way on this course platform. And then you have all the tools for you to go through this online module, but then also to really work with the data and also do the practical case study, which we developed for you. So in order to be able to access this course platform, you have to, if you're not yet registered, to the ltpy.adamplatform.eu. And so you have to go to login.ltpy.adamplatform.eu. And if you don't have an account yet, then you can go here to sign up for a new account. You will receive an email. You have to click on the link, and then you will have your account set up. And once you have your account, then you can here log in with your username and password. And then basically once you're logged in, you can go to dust.ltpy.atomplatform.eu, and then you will be able to log in to this Jupyter Hub. And once you entered the Jupyter Hub, this is how the interface looks like. So you will have here on the left a menu with different folders, and also 2 notebooks shown, like an index notebook, and also the license of the entire course. And so the folders are organized as it is on the online module. So we have a folder for observations, and if you open here, if we go to, if we click on this folder, then we distinguished again between satellite observations and ground-based observations. And then we have if we go back to the main menu, then we have a folder on model forecasts, and we also have the practical case study. So it is really reflected the same structure as you see on the online module. The folder EO data. So this is all. This folder has all the data already available for you in order to be able to run the notebooks under observations and model forecasts. And the practical case study, there is a set of exercises where you are also asked for yourself to retrieve specific data. But let's go to observations, and then let's say satellite. And then you see basically for the, so if we go back to the online module and the satellite observations, for the same data, we introduce you here in the module, like for example, RGB composites from the MEEO second generation Fierli instrument. You see then here also the notebook for this. And if you open, so if you double click on this notebook, then you see here an introduction. So actually the same content as you see here on the online module, just with the difference that now you can also execute it. So you can here highlight as a cell, and then you can go, for example, here to this arrow, and then you can run this notebook. So this helps you also to really actively working with the data. The course works with a set of helper functions, and most notebooks will also not only load Python libraries, but also a notebook that is called functions. And if you want to see specifically what functions are available, you can go again to the main folder and then open the functions notebook here. And there you see a set of 14 different functions that just help you to, it's like a set of general functions that help you to handle different type of data in a more general way. We use specifically, we apply these functions, for example, to do a geographical subset or to visualize data with a specific matplotlib function. And there are like, two functions which we will reuse quite often for different type of data. And so basically then I will go just for the remaining 10 minutes go through 3 examples under these under the observations, model forecasts, and model forecast data, and then I will also show you the practical case study. But for you to be able to go through the practical case study, as a prerequisite, we really recommend you to go through all the notebooks of the observations data, so satellite and ground-based data, and then also the model forecasts. And so basically an example here from MEEO second generation RGB composites, it introduces you to where the data can be found. The data is already on the course platform. We also show you then how you can open data. So here we, in the folder EU data and satellite, MEEO-SAT, and then for a specific event, we want to capture all the data with the format NAT. And then there is the Python library SatPy, which can be used to specifically for MEEO-SAT second generation data to load this data. And this is a very effective library to handle MSG Fierli data. And so the notebook basically introduces you to how you can use the SatPy library to load a scene from the MEEO-SAT second generation. Fierli instrument, I not go through everything, but the nice thing with the SatPy library is also that it makes it quite, or it facilitates to create RGB composites, and there are different composites available, and these composites, they already have assigned different like the band combinations for RGB composites, depending on what you want to highlight. And there are two composites which we specifically show you in these notebooks, and one is the natural color. So as the satellite observes it, or as we observe it. But then also there is a specific composite for dust. And so basically this is here an example how for the natural color RGB composite, and all the notebooks for the introduction part, they highlight specifically an event, a dust event that occurred at the beginning of February in 2021 over Europe. And this was like where Saharan dust came over the Mediterranean, and also specifically came to parts of Spain and France, and also parts of northern, like Germany, for example, Northern Europe. And we will, and like going through the notebooks, you will see how different types of data specifically monitored or forecasted this specific dust event. And so this is how a RGB natural color composite looks like, specifically for the 6th of February 2021. And then we showcase you some other functionalities of the Python library, but then and also an example how you can visualize it with country borders, for example. But then also at the end, we showcase you also the dust composite, which really highlights dust phenomena. And everything you see here in pink is dust. And so you see here the dust over the Mediterranean, but also specifically here where we actually had clouds. And you see here a very strong dust signal actually below the clouds. So for this specific scene here. And so, yeah, if we go here to the satellite, so please do go through the different notebooks we prepared you. So we have another example for level 1 RGB composite from the MODIS instrument. And then we have three different examples of level 2 retrievals, like from the Sentinel-5P Tropomi aerosol index, then also from MODIS, they have an aerosol product and a multi-sensor product, PMAP, which also offers a retrieved aerosol optical depth level 2 product. And we also have an example of the absorbing aerosol index level 3 product from the GOME2 instrument. And then from the ground-based ones, I will shortly go through the AeroNet example, for example. So AeroNet are observation data that provide you data from observation stations worldwide on a sub-daily and daily aggregates. And the notebook here really guides you through how you can select a specific station and how you can also programmatically download the data. So here we show you an example how to get the data from the station in Palma de Mallorca for the entire February. So you can download the data, and then how you can also read the data because you download them in a text format, how you can read it with the pandas library, and how the data looks like. So it provides you here on a sub-daily like every 5 minutes measurements, if a measurement is available, and then aerosol optical depth information at different wavelengths. But if you also scroll a bit further, so you get quite extensive information, because from these observation stations you also get the angstrom exponent, and also you get in the online module more information about how you can also combine aerosol optical depth and angstrom exponent in order to differentiate dust particles. And so then basically we also show you how you can visualize here the aerosol optical depth data from the AeroNet network and this is the example for the entire February. And you see here for this specific dust event at the beginning of February, you see here higher or elevated AOD values. So it was also seen and observed by the AeroNet station in Palma de Mallorca. And the other example again here is that basically we highlight, so we use the daily aggregates and we use the angstrom, the aerosol optical depth at different wavelengths together with the angstrom exponent. And this is always a good indicator here that, like, if the angstrom exponent is below 0.6 and you have higher aerosol optical depth values, that this event was here related to dust. And then another example also for model forecasts. So we use here, for example, the regional dust predictions from the Monarch model, which Sara also introduced you to. And so there basically you get here also access details, how you can access the data from the Monarch model, and then you can download the data, and the data is already available, so in NetCDF format. This is the nice thing with model data, because they are modeled, so they are very organized, and so you can open them with X-array here. And you see here in a 3-dimensional format, the Monarch model gives you every 3 hours for up to 3 days ahead forecasts of optical depth and also surface concentration on dust. And then we showcase you how to load the variable, and then also how to visualize it from the model. And this is for one specific time step, but we have 25 different time steps. And so then we also showcase you how you can animate the dust forecast for over the 3 days. And here basically this is a very nice animation, how you can see how the dust, like the Saharan dust, really also came on the 5th and 6th of February 2021 from Northern Africa to Spain and France, and really also captured parts of Germany and also Eastern Europe. And similar examples then you also find on the CAMS global forecast, which has a lower resolution than the Monarch model, and also the CAMS European air quality forecast, which is also a regional model forecast, which has the same resolution than the Monarch model, but also is limited to Europe and is not available on a global scale. And with this, basically, so if you go through these data examples and all the notebooks, you should have a good understanding of to be able to go through the practical case study which we developed. And if you go to the online module, so you can find the practical case study here. So the specific exercises, there are 5 different exercises we developed. And if I open the first one, is basically that we guide you in a step-by-step manner to really reflect on on a problem, on analyzing a specific dust event which occurred in February 2020 over the Canary Islands. So it's also a real dust event that took place. And each exercise starts also with a brainstorming exercise where we ask you some guiding questions on, okay, what data would you actually use, or what data can be used to tackle this problem which we give you. And this is so really a really nice opportunity for you to really reflect on the advantages but also limitations of all the data sets which we introduce you, because I think one of the take-home messages you can take from this short course today from Anu-Maija, Sara, and also Lucia is that basically you need, like, in order to analyze dust in a comprehensive way, is that you need a combination of satellite data, ground-based measurements, and also model forecasts. And if you go through these exercises, you will also see why you need all the 3 different types to actually analyze it, because all the data, they have their specific advantages, but then also limitations. With each exercise, of course, we also provide you solutions, but what we also say here, of course, this is a self-paced course, so it's not that you get graded for it. But again, for the best learning outcome is achieved if you do the exercises first by yourself, and then you compare the solution with the solutions provided here and also on the training platform. And if you go here to the practical case study folder on the training platform, on the course platform, you have for each exercise, you have also a notebook where you can directly start working on the solution. And then we have a specific folder where you can also compare your solution with the solutions from us. And then, yeah, and with this, I would now stop sharing my screen. And the last thing what I also want you to, or what I want you to ask is that on Slido, there is still the opportunity to ask questions, so we can then also respond to these questions. But I also want to ask you that we have a feedback form of the course. It's like 4 questions, so it should be really quick. It is also available on Slido, and I really would like to invite you to also give us feedback, how you like this course, what you didn't like, and also some proposals for future short courses, because this really helps us to offer exactly the content you would like to see and you're interested in, but also to improve the existing content. And with this, I would like to thank everyone for today, and also thank you for staying already longer, 4 minutes longer. And thank you again for joining today. And I wish you a nice remaining day, evening, afternoon. Thank you.